Sets are the second type of collection types in Swift, and we will be discussing some of its properties in this tutorial. Sets are very similar to arrays, but there are a number of differences. Firstly, the elements of sets are not ordered. Secondly, the elements of sets are unique. They cannot be equal. And also, unlike arrays, we're not using any indexing when we're dealing with sets. Here I'm showing an example of the contents of a set. We have 4 different values, and they're not in any particular order. So for instance, here we have v1, v2, v3, v0. There is no particular order there. We might as well write this as v2, v1, v3, v0, or any other combination. It doesn't make any difference in the contents of the set. Also, like arrays, the elements of sets of a set are all of the same type. Declaration of sets can be done in a similar way to the declaration of arrays. Here there are 2 examples. The first example is when we have declaration alone. As it can be seen, the difference between this declaration and the equivalent array declaration is the substitution of the word array with set. So here we have a variable called x1, which is being declared as type set of integers. So again, it's set of integers and not just integers. Similar to arrays, we can use the initializer format. What this does, it actually returns an empty set, which is assigned to our variable x1 here. Note the difference in syntax here. In the case of declaration alone, we are using colon here, whereas in this case we're using the equal sign. And the other difference is that this is declaration alone, no assignment, whereas this one is declaration and at the same time assignment of an empty set to x1. We could simultaneously declare and assign to sets. Similar to arrays, that could be done by explicitly showing the type of the variable or constant that we're declaring, or we can do it using inference. In the case of explicit type declaration, we can use this format, which is again very similar to what we use in the case of arrays. We're doing declaration first, so x2 is a variable of type set of integers, and then we're doing assignment. When we're doing assignment, we use array literals to do the assignment. So here, although this is showing an array, this is understood by Swift to be a set. So x2 here, which is a set of integers, will be assigned this value. An alternative to the above, which is a shorthand, is that we don't have to mention the actual element type when the literals indicating what the type of the elements is. So in this particular case, the array literal that we're using indicates that the elements are of type integer, and the word set here is indicating x2 is a set. So putting these two together, Swift determines that x2 is of type set of integers. Using inference is shown in these two examples. This is again similar to the case of arrays. We're just using the keyword set instead of array here. And within the brackets, the initialization values that we are going to be using will again be entered as array literals. So what this expression is indicating is that by just first looking at the right hand side of this, we are saying that we are creating a set of integers and initializing that set to be of value 1 and 2, and because we are not explicitly showing the type of x1, Swift, by looking at the right hand side of this equation, realizes that it is dealing with a set of integers, and it automatically determines that x1 is of type set of integers. This is the shorthand version of the above, and it means exactly the same thing. Like arrays, we could use this arrangement to assign or reassign a value of a set. Again, we can use array literals when doing assignment or reassignment. Here, it should be noted that the declaration of x1 is assumed. Similar to arrays, empty sets are shown by empty square brackets, like so. Here's an example. So x1 is a variable of type set of integers whose value is equal to an empty set. Again, similar to arrays, if in the future we need to reassign a value to x1, we have to make sure that that value is of type set of integers. It cannot be of any other type. It cannot be a set of doubles or set of floats, set of strings. If we mistakenly assign such values to x1, we will see some runtime error. Some typical set operations are shown on this slide. For instance, if we need to count the number of elements of a given set, we could use .count, very similar to arrays. So in this example here, x is a constant of type set of strings, and we are assigning these two values to the set, string 1, string 2. Again, note that we are using the string literals for assignment purposes. In the second, in the following line of code, x.count counts the number of elements of x and return the value to our constant y. In this example, y will be equal to 2. If you need to check whether a set is empty or not, we use dot is empty, again similar to arrays. So for our constant x with these contents, x dot is empty returns a boolean. It is that the value of that boolean is true if our set is empty, and it will be false if our set is not empty. In this case, as our set is not empty, y will become equal to false. If you'd like to check whether a set contains a particular element, we use dot contains. Inside brackets, we insert the value that we're looking for. So in this example, our variable x contains these values. It's a set of integers containing these values. X dot contains 10 looks for 10 in this set. If that value exists in the set, it returns a value of true, which will be assigned to y. Otherwise, it returns false, which is assigned to y. In this example, y is equal to false because 10 is not part of the set. Dot sorted could also be used here with sets as it was used with arrays to sort the elements of a set in an ascending order. So here x dot sorted will generate an array whose elements are the contents of our set x, and those elements are ordered in an ascending order. So here we see the contents of x which are not ordered, but after applying dot sorted to x, the generated array is 1, 2, 3, 4, 5, which is a sorted version of this literal, and that value which is the value which is returned by dot sorted is assigned to y. It's important to note that the return value of dot sorted here is not a set, but it's an array whose elements are the sorted version of our of the contents of our set. We can do fundamental set operations in Swift. For instance, for these different constant sets x, y, and z, we can use union, which is a keyword, to find the union between x and y. So this expression evaluates the union between the set x and y. So we have x and y here. The union is the result of putting these two together. So we will getting 1, 2, 0, 3, which, so the return value here is another set. So again, the order is of no importance. Notice that I'm showing curly brackets here to indicate that we are dealing with a set and not an array. Also notice that when we do the union, both x and y contain 3, but in the case of sets, we are not allowed to have repeat values, so we only insert 1, 3 in the outcome of this union operation. Intersection finds the intersection between x and y. So notice that the two arguments are mentioned at the beginning and inside the brackets. So the intersection of x and y in this example is going to be 3. 3 is the only value which is shared between the two. The operation subtracting is between x and z this time. So what this does is subtracting starts with x as the first input, which contains 1 and 3. Then it looks at the second argument, which contains 2, 3, and 5, and takes away from the first argument all the set values which exist in the second set. So in this particular case, 3 is the only value. So taking away 3 from x, we will be left with a set whose content is equal to 1. And finally, symmetric difference. Again, we have two arguments, x and z. In this particular case, what we see is we just take these two sets, put them together, and take away all the elements which are in common. So in this particular case, 3 is the only element which is in common. So what we will be left with is 1, 2, and 5. And this is what we are showing here. Again, notice that the outcome of all these operations is another set. If we need to find various relationships between different sets, we can follow some of the operations that I'm showing in these examples. For instance, for these 3 sets that I've defined here, what I'm doing here is I'm using the equal to operation here. Outcome of this would be false or true, depending on whether these two are equal sets. And that return value will be assigned to x1 in this particular case. So x is shown here and y is shown as the second line of this code. These two are not the same, so as a result the outcome of this comparison is going to be false, which is assigned to x1, and I'm showing that here. We could use the not equal to operation if we wish to, instead of this, and the outcome of that would be opposite to whatever we're getting in the case of equal to operation. We can check whether a set is a subset of another by using this structure. Z dot is subset of X. So these are again the keywords that we have to use, and notice the use of parentheses in front of is subset. So we check whether Z is a subset of X. Here Z is given by this set and X is given by that set, and because 5 and 3 are all also elements of X, we realize that Z is a part of X. So the outcome of this, which is a Boolean, is going to be true, and as a result X2 will be true. Conversely, we can check whether X is a superset of Z, and we use this structure to check that. Use of the keyword is superset, followed by parentheses. Inside parentheses again we have of and colon. So by comparing X and Z, as these two were related before, where Z was a subset of X, X must be a superset of Z, and as a result the return value of this must also be true, and as we're showing here. We can also check whether two sets, in this case Y and X, have any common values. To do that we use this keyword is disjoint, and inside parentheses we have with, following by colon. So if these two are completely different, there is no elements that they have in common, the outcome of this will be true. Otherwise, if they have even a single element which are in common, the outcome will be false. Now, checking the two sets, Y and X, we can see that there is one element in common here. So as a result, the outcome of this operation is going to be the Boolean false, which is shown here. Similar to arrays, we can insert and remove elements. That is what I'm discussing on this slide. So to insert an element into a set, we use .insert. That's one way to do this. So for a variable x of type set of integers, which is equal to this, if we wish to insert another integer into this set, which in this case is 3, we can use this, which says x dot insert inside brackets, we have the value of 3. So this inserts 3 inside this, and the outcome will be this. So x will be a set whose contents are 1, 3, and 2. Again, notice that because this is a set, order is of no importance. One thing to notice here is if the value that we wish to insert into a set already exists, that is not a problem, but when we do that, it does not, the insertion of that value will not make any difference in the contents of our set. For instance, if instead of 3 here we wanted to insert a 2, x would be left as it is, because we are not allowed to have repeated values in a set. So as a result of that operation, we only would see one of the 2's, and the original set would not be changed. We could also remove elements of a set by using the keyword remove. So here we have a variable x, which is of type set of integers. Then we wish to remove one of its elements, 2 here. So we use this structure, x.remove, inside brackets the value of 2. The outcome of this would be the set of x with the value of 2 removed. So this would be the contents of x after this operation. What this thing returns is the element which was removed from the set, in this case 2, and the value is assigned to y. An important thing here is that because in the process of removing an element, that element may or may not be part of the set. If you don't know whether it is a part or whether it is or it is not a part of the set, we could still use this operation, but because of this possibility that the element is not actually a part of the original set, the return value will be of an optional type. The reason that optional is used is because the return value may or may not exist, and this is the main reason that we used optionals in the past. So in this case, 2 is returned to y, and the type of y is going to be an optional, and it's going to be an integer. And the reason that it is integer is because the removed value was of type integer. Now, I am showing a case where we try to remove a value 10 from our set, and that value does not exist. It's not part of this set. So this operation is still allowed, but what is actually returned is nil. Right? It should be clear here that why we have the return values of type optional, because the return value may or may not exist. If we wish to remove all the elements of a set, like in the case of arrays, we can use the remove all keyword, and this is the example that I'm showing here. And what will be left in our original set is nothing, so it's an empty set. We can iterate through the elements of a set as we did in the case of arrays. For a variable x defined as set of integers with these values, we can use a for-in loop. What the for-in loop does here is it takes x, and x generates the set of elements of the contents of x, and assign those one by one to this temporary variable that I'm calling lm, short for element, and those values then are used in the body of the for loop. As I mentioned before, sorted can be used to order the elements of a set. So inside the for-in loop that I just mentioned, we could first sort this by using x.sorted. That would return an array which contains the same elements as this set, but the elements are put in an ascending order, and those ordered elements are assigned to our temporary variable element lm here, and like before, that variable can be used inside body of the for loop. This concludes our discussion of sets as part of the collection types in Swift.